The workings of modern society rely on cryptography for the secure transfer of data from point to point. Without it, eavesdroppers could read this data and act upon it maliciously without the user knowing. It would be possible for bank transfers to be directed to different accounts, and passwords could be easily viewed over the web. As more and more private data is being stored on the web, the need for security is stronger than ever. The fundamental principle of modern encryption is that it should be impossible for a person to decrypt a piece of data without knowing the secret key associated to it. While theoretically this may be the case, in reality it's just not possible. According to Moore's law, the speed of a computer is approximately doubled every 2 years. What this means is that encryption is becoming easier to crack. One of the first standardized forms of encryption was the Data Encryption Standard, or DES, created in 1977 by IBM, and was the best encryption practice for many years. It used a 56-bit key, which meant that there were approximately 72 quadrillion password possibilities. It was thought to be impossible to crack at the time. That was until it was cracked in 1997 by the DES Child project, taking a total of 96 days. It was later cracked again by Distributed.net in January of 1998, taking a total of 39 days. A major development in DES cracking was when the Electronic Frontier Foundation created the EFF DES cracker machine in February of 1998. It was nicknamed Deep Crack, named after IBM's Deep Blue chess computer. It was capable of cracking any DES cipher in less than 56 hours and was later optimized to crack DES in less than 22 hours. To counter these fast crack times, Triple DES was created, which involved performing the DES algorithm 3 times for encryption and decryption. Triple DES therefore became an unpopular choice for protection of data due to its intensive computational power requirements. One of the major breakthroughs of modern cryptography was the transition from the Data Encryption Standard to the Advanced Encryption Standard, or it is known as AES. It was developed by 2 Belgian cryptographers, Vincent Reimann and Johan Damon, in 1998 for a competition hosted by the US National Institute of Standards and Technology, winning them first place and later becoming the standard in 2001. AES is computationally fast in both hardware and software and is built into many Intel chips. It is currently considered to be secure against binary computer systems because it relies on the mathematical properties of prime numbers and large key sizes. It uses either a 128, 192 or 256-bit key, which is a huge leap over the DES algorithm which only used a 56-bit key. AES has revolutionized security and its implementation. It is built into most modern-day web applications and we rely on it to protect our private data. It is predicted that quantum computing will break all modern encryption that rely on prime numbers. So I guess the future encryption lies within the use of quantum mechanics. It will be interesting to see what breakthroughs will come out during that time.